All right, section 4-3, exploring. Don't they make it sound exciting? Exploring congruent triangles. My writing is falling apart today. What's up with that? Okay. There's really only 3 things you're going to have to write down that you're going to need to know today. The first thing is called congruence transformations. Whoops, transformations. Do you remember what transformations are from algebra? Yes, what's a slide really called? You're not allowed to call it a slide. That's very middle school. Now, if you haven't had a teacher teach it to you properly, oh, for shame on that teacher. So who can tell me what a slide's really called? Okay, if you had me last year, you should know this. Nope. Starts with a T. We talked about this. Translation. All right, so a slide is a transformation. What else? So translation, reflection. What's a turn? Rotation. What goes bigger and smaller? Dilation. Out of those 4, which of them gives you congruent figures? In other words, the figure doesn't change shape or size. So if you translate something, which is to slide it, does it change shape? No. If you turn something, does it change shape? No. If you flip something, reflect it, does it change shape? If you dilate something, bigger or smaller, does it change shape? Yes. So out of those 4, the dilation is the only one that doesn't give us a congruent figure. So your congruence transformations would be translations. And I'm going to put this in parentheses only to jog your memory of what it is, but you're not allowed to call it this. That's a slide. But they're purely for your notes to jog your memory. So translations, rotations, which are turns, and reflections, which is a flip. You're going to be given pictures of triangles, and they might be translated, rotated, or reflected. Me personally, when I look at that, it's hard for me to tell if they're congruent figures because my eyes don't work as most people's do. If you're very spatially oriented, then you will have no issue. You'll be able to look at a picture, the 2 pictures, and you'll be able to figure out which points on which triangles correspond to each other. I personally can't do that. I have to rewrite the triangles so that they're oriented correctly. Otherwise, I can't see it. Or I have to use my knowledge of arc marks and tick marks to help with that. And so for most of you, you're going to have to do that. So don't look at a picture if it's translated, rotated, or reflected. Redraw it so that both triangles are oriented the same. They're turned, flipped, or slid correctly. And I'll show you a picture of what that means in a minute. And then we have a theorem that we're going to use. Theorem 4.4. It's a very popular theorem in proofs. And it says, congruence of triangles is reflexive, symmetric, and transitive. Aren't those properties of equality? Now they're properties of congruent triangles as well. Remember, the reflexive property of equality says with congruent triangles you're going to see something like this. Angle A is congruent to angle A. The left side looks exactly like the right side. Whereas with the symmetric property, you'll see angle A is equal to angle B. Angle B is congruent to angle A. The left side and the right side will flip. Whereas the transitive property follows that pattern: A equals B, B equals C, A equals C. when you're writing this, and this is going to be a reason in a proof, when you write this as a reason of proof, you can use shorthand notation. Your shorthand notation will look like this. Congruence will be the congruent symbol. Of triangles, you'll just write a triangle, is, and then you're going to put in one of those three, not all three, just one of them, whichever one relates to the statement that you've been given or you came up with. In this chapter, you're going to be given half the statements and half the reasons. The next chapter, you'll have to do full proofs. So, and I might make you do a full proof because the congruent triangle theorems are really simple and easy. But maybe we'll save that for next chapter. All right, so there's that. Then I want you to write down the following. Can I flip this? Nobody's upset. Awesome. All right, I want you to write down this definition. You smell something burning? Yeah. It's burnt popcorn, I'll guarantee it. When I was pregnant with my daughter, oh, that would send me to the bathroom. It's a terrible smell. All right, so write this down. This is another extremely popular reason when doing congruent triangle proofs. Definition of congruent triangles. I won't let you say that though. But it says two triangles are congruent if and only if their corresponding parts are congruent. Our job when we prove triangles congruent is to prove that all parts on both triangles are congruent. And corresponding parts means parts that are in the same spot. What kind of parts are on triangles? What? Sides. Not all triangles have legs. It depends on the kind of triangle. But they all have sides, don't they? They all have three sides. What else do they have? Three angles. So between two triangles, there will be 6 pairs of corresponding parts. 3 pairs related to angles, 3 pairs related to sides. Did you write this down already? Really? Now, we actually don't have to write all of that in our proof. We have a much shortened form, and it's really catchy, and you have to learn it. So write this down. In the proof, it's going to be known as CPCTC. So write it down. I'll explain how we got that. This is generally the very last reason in a congruent triangle proof. Why? Because of CPCTC. It'd be nice if you knew what that meant, though. True? Here's what it means. CPCTC relates to corresponding parts of congruent triangles oops, I can't even spell R today. Are congruent. So here's where the CPCTC comes from. C, corresponding. P, parts. Of doesn't come into play. C, congruent. T, triangle. R doesn't come into play. C. So here's CPCTC. Know it, learn it, love it. CPCTC. Now, usually I get some of those letters on there, but some of them are put in there wrong. If you use CPCTC, rather than write out, you could either put CPCTC, or you could write out corresponding parts of congruent triangles are congruent. It's kind of catchy, right? You can kind of do a rap to it. I personally would never try to rap because it'd be scary. Scarier than the triangle song. But if you can't memorize this properly, then you better write this out. Because oftentimes I'll have kids going CCTC or CPTC. If you miss any of the letters, you're going to get partial credit. So either learn it properly or don't use it at all. Okay? And all that says is if you have congruent triangles, all of their corresponding parts, the right angles, and I'm going to show you what corresponding parts in a minute, all the correct angles and all the correct sides that relate to each other are congruent. All right, so let's look at some problems. first problem is this one. Get it out of the glare. Alright. So there's your first problem. Name the corresponding parts if, and this is really important, they've given you what is called a triangle congruence statement. They said that triangle PQR is congruent to triangle STU. That congruence statement is actually telling you which angles correspond to each other. Which angles are exactly the same measure. You're going to use that in your knowledge to redraw your triangles, because right now, do those triangles look like they're oriented correctly? Do they look like they're tilted in the same direction? One's tilting right and one's tilting left, aren't they? This is actually a reflection of this one. If I were to reflect this, that's what I would have. So what I would do, the minute I got this problem, I would redraw the triangles. I would leave one of them alone, but I would change this one. And I would use my triangle congruent statement to do so. This says that angle P corresponds to angle S. They ought to be in the same position. Isn't angle P down here in the lower left? This should be angle S here, is it? No. So I would change that to read angle S. And then angle Q is in the middle. That means that angle T corresponds to angle Q. So if Q is in the lower right, then T had better be in the lower right here. Do you see how they change places? And then the last letter R corresponds to U. And doesn't or R correspond to U, so I don't have to change that. It's really important that you get this picture drawn correctly. They have to be oriented the same. The majority of you have to be able to see it this way in order to draw out the corresponding side parts. They're asking you to name the corresponding parts. You have to give me 6 different items. So for the first one, P, angle P, you're going to use a correspondence statement, because if the triangles are congruent, aren't all their corresponding parts congruent per the definition? So angle P is congruent to angle S, angle Q is congruent to angle T, angle R is congruent to angle U. Those are your angles. You don't even have the picture. You don't need to have the picture to write that out. Can't you follow that from the triangle congruent statements? But you do need the picture for your sides. It'd be really helpful. If you're not given a picture, I would draw a picture and label them in the proper order so that I could look at the sides. Doesn't PR, what does PR correspond to on the other triangle? Isn't SU and PR in the same position? So SU. What does PQ correspond to? PQ here. ST. And the last one is RQ. What does it correspond to? UT. That's all they're asking you to do. When you name all the corresponding parts, you need to write it as a congruent statement. Questions on that? It's pretty simple, yes? Can I erase it? Okay. Let's look at the other type of problem you're going to get. Other type of problem looks like this. Let's start with the first one. Alright, so let's look at this one. Your job now is to do the reverse. You get to write the congruent statement. But they've given you a picture. Are the triangles oriented correctly? Are they? No, they're not. But we know that these are congruent to these, but notice they've given you a bunch of arc marks and a bunch of tick marks. Use that to your advantage. I don't actually have to redraw this so that they're oriented correctly, because all I care about are the arc marks. I could care less about the side tick marks. It means nothing to me. Because if I'm making a triangle congruent statement, I'm trying to figure out what corresponds to D. Look over here at D. How many arc marks does it have? It's really 3. It's got 3. 2 are up here on L. So if D has 3 on this triangle, which of these has 3 on the other triangle? T. So D corresponds to T, so I'm going to put a T there. It has to come first. The next letter is X, and on this particular picture, don't the two triangles share two angles that are the same? So on this one, X's here, both X's are the same. They both have single arc marks. So X comes next. And then L is the last one. L is last on that one. So I'm going to let you look at 3 and figure that one out on your own. 4, 3, by the way, this is M, R, N is in Nancy. Use your knowledge of single, double arc marks. What else do you have to use your knowledge of? What's special about something up there? Angle M is missing arc marks. Why do you not need them? Because they're vertical angles. Don't we already know, or shouldn't you already know, that vertical angles are congruent? So if you wanted to, you could put triple arc marks in here to make yourself feel better, if you needed to do that. So which one corresponds to M? M, same one, right? Next one's R. What corresponds to R over on the other side? 2 arc marks. J has 2 arc marks, so there's J. What corresponds to N as in Nancy? 1 arc mark, 1 arc mark. Do you see how I didn't even care about the tick marks? Now if they had asked me to list out, I could give you a picture just like this. Instead of the triangle congruent statement, I'd ask you to list out corresponding parts. I love it when they give me arc marks and tick marks, because then I don't have to redraw the picture. Can't you just match up tick marks and arc marks? What's the corresponding side to JM? 1 single tick mark. RM, see how that one has 1 single tick mark? Did I have to redraw this triangle so that it's oriented the same as that one? No. But if they were missing those tick marks and arc marks, then we would need to do that. Any questions on how to write a triangle congruent statement or how to list out congruent parts? All right, your other job is to learn the theorem 4.4, learn what it says, not theorem 4.4, and learn your definition of congruent triangles, CPCTC.